Hello YouTube, and welcome to Torbjörn teaches himself to give lectures online. This is the first lecture I've ever tried posting, so this might go a bit slowly. I've chosen my thesis presentation just to have something to talk about. I did a thesis on RepRap assembly workshops and the software people use on RepRap assembly workshops. I did this 2 years ago now. It's not obvious in the title that I developed a tool that runs on USB sticks, but the term live software is really USB sticks that you can boot an operating system from, and that operating system then contains everything that you need for your purpose. Our purpose was RepRap assembly workshops, and this rose of green is not clear either, but I will describe it later. This is just a table of contents. It tells you that we're going to talk about RepRap, we're going to talk about software, we did an experiment. The experiment went well, but there are of course problems and things that could have gone better. The background for the whole thesis was this observation that productivity is increasing. People can produce more stuff per hour they work compared to before, but they don't get the money back. Part of it is going to other places. This fact is not really very controversial. I have included the most positive way of counting median income, and I've included the most maybe negative way of counting median income, and they differ 20-30% something, but there's still a huge gap up to the real productivity increase. And this is a very long-term trend that you can see all over the Western world, and I'm an engineer, so I wanted to do something about it by building machines, because that's what engineers do. I would like to build machines that reach median Americans, median Europeans really, and maybe also median Asians and Africans. I just don't know very much about Asia and Africa, and that's too bad. I did this comparison between cars and 3D printers, because cars are machines that have reached the median Western family and made them a whole lot freer and richer, and they love their cars. So I would like to see that happen to 3D printers as well. And I found the RepRap project to work that had done some previous art, lots of previous art, and I compared what they do to what Henry Ford did. So I've kept the Henry Ford model on the left and the RepRap model on the right, because there's a huge difference in how cars are produced and how RepRaps are produced, or how they're supposed to be produced. On the left we see a large scale production model with a centralized factory. The green arrows here are money, and the red arrows are goods. The factory gets lots of money in, or the large company get lots of money, and they produce lots of goods cheaply and distribute it widely, and then they pay some taxes and salaries and stuff back to the people, trying to create a positive feedback loop, hopefully. RepRaps are distributed differently. The red arrows still represent goods. RepRaps create goods for their owners. And here we have some black arrows as well, and that is copies of the machine itself. So the RepRaps produce goods, and they produce copies of themselves, or improved copies of themselves, sometimes, if their owners are RepRap designers. The new machines get distributed to machine customers, or friends, or people that are physically close to the owner of the RepRap, typically, or at least in this model. In practice, they get sent by mail a lot in packages, but still, the RepRap producers often do it in quite a small scale. And the person who receives the copied RepRap machine gets the power to themselves copy their copied RepRap machine and keep this chain of machine distribution going, as well as the freedom to produce goods to themselves. So RepRap has done, in addition to being cheap, being simple, being well documented, they have also added software freedom. That is the system on the right here, but for software that can copy itself, that users can study, use as they wish, improve and redistribute and sell. And RepRap has also done self-manufacture, that is the same thing but for hardware. You can produce the physical stuff you want with the RepRap. You can improve the RepRap itself. You can distribute the improved versions of your RepRap machine. That was not true in the age of cars. So I wanted to, of course, have a measure of how well does this chain of distribution develop. Does RepRap really spread from person to person? So I draw these diagrams where a node is a RepRap owner, or a group of RepRap owners, and the arrows between people are transmitting of a RepRap machine. So when a new person or a new group gets to own a RepRap machine, it gets transmitted from another RepRap owner. That transmission is written out like an arrow. When you draw out the distribution of RepRaps like this, then you can start measuring how viral is this distribution really. On the left is an example network, a very small one. On the right here is an actual network of RepRap distribution that was recorded in Spain. So every green dot is a Spanish person or a group of Spanish people who owns RepRaps. And all the little black arrows you see are transmissions of RepRap self-replicated parts. Let's see if I can zoom. No, I can't. You can see small clusters. It looks like some of the RepRap owners were very active with distributing RepRaps to others, and that is actually because they arranged weekend events where they distributed RepRap machines to many people at once. These events are called RepRap assembly workshops, and I found them to be very important to the RepRap way of distributing machines. I also found that the most popular RepRap machines were largely largely distributed in this way for a few years before they went large scale, before there were any factories, stuff like that. So the power to get to arrange these events gave RepRap 3D printers an advantage compared to other 3D printers. And this advantage still exists actually. It's just that it's a bit harder maybe to sell weekend events now, since RepRaps or 3D printers are so widely available anyways. But I narrowed in on these events. I wanted to help them, make them easier, and I went to find out what is the bottlenecks for making them better. And the big bottleneck is software, because people who build physical production machines, they don't want to also have to worry about software a lot. Often they don't have software training from before, they are not engineers. They're just interested hobbyists or people on the street, artists, architects, people like that who want to 3D print, but they don't know how to program. So we need to put together something that is plug and play, and that includes all the important programs in a pre-configured way. Actually, when you do 3D printing, you will bump into lots of programs, and I chosen the 5 most frequent ones, the 5 most widely used programs for 3D printing. They do different things, and you need all 5 of them. So that was the challenge. We needed to find a solution, and the solution we ended up on was a piece of hardware that can itself replicate at least its information contents, and that is a USB stick. You can see icons for all those 5 programs in here, and a new icon showing up that represents the operating system that can boot from a USB stick. I've chosen one that is called Proteus. That's not very important. I chose it just because it's small. Other operating systems would have worked as well. So we needed to configure all the software, create these USB sticks, arrange a RepRap assembly workshop, and see if this worked, if it actually helped the workshop or not. Yeah, so this is how it looked like. The operating system looks like Windows 95 maybe. It looks like an operating system that the users would feel comfortable with. I think you can see all the 5 programs represented here. We got into arranging workshop with 11 groups of participants. Some were in pairs, I think some were alone. Maybe one group were 3 people. I don't remember. There were 11 groups, but 5 of them actually failed to boot the operating system. And they were supposed to insert the USB stick into the machine before they switched it on, and when switching it on, they were supposed to find the way to tell the computer that, hey, there's a live operating system plugged in your USB port. Use that operating system instead of Windows or Mac OS or GNU Linux or whatever they had from before. This turned out to be hard on some laptops that participants brought, particularly MacBook laptops were a very common kind. 2 of 11 had them, and we couldn't get them to boot the USB stick. The last 3, we don't really have exact collected data about why they failed. Because there were 2 instructors and 11 participants. I think there were 20 something people in that same room, all of them asking for software assistance at once. So the data wasn't pretty after that. the instructors basically tried to help everybody instead of doing this research. Yeah, but we did the questionnaire afterwards, and people did say that they needed more instructors on the software, just getting it to boot. But when we asked people after the workshop what was their hindering them for arranging RepRap workshops themselves, they had multiple concerns, not only not dominantly just software concerns. They actually weren't very concerned about getting the software being hard at all, and that's a positive result, because it shows that we managed to get at least the software difficulty down to the level of maybe the difficulty of other parts of the workshop. No one mentioned software as a special challenge or hindrance to hosting workshops. So that's very cool. I should mention that the USB sticks, they could self-replicate. So if you just buy a bunch of USB sticks, boot up the one you got at the workshop, and plug them into your computer one by one, and tell the computer in a graphical interface, I want to copy the live operating system over to this new USB stick as well. It will do that quite easily without the using being a computer wizard. The instructors' names were Katarina and Martin, and they were very happy with the USB sticks. They are not computer wizards themselves, but I should say they are. I think they are both engineers. I think even they both have PhDs, so they are not representative of the average American maybe, but they were happy with the USB stick. Yes, we find the most important thing that the live operating system tool can do is to shorten the RepRap assembly workshop. Martin and Katarina tried to do this RepRap assembly workshop in one day, which is not the standard way of doing it. A weekend is the standard, but they want to be leaner, faster, push the limits, and that is maybe with good reason, because the participants turn out that they had less and less energy and less enthusiasm throughout the day, and at the end of the day many of them were very tired and frustrated. So if you can shorten the workshop, that improves the workshop. Yes, so for further research, further tests, the main goal should be to get all participants to boot the software so that it actually gets used by themselves on their own computer. It helps to have trained instructors and prepare them for this boot step. I'm actually going to arrange RepRap assembly workshop myself around the hand printer this May, and I will set aside the whole Friday just for booting the live operating system, so that everybody is on board, and then all the information, all the assembly manuals, everything is on that system, so when they have booted they are almost at home, they're half finished. That is the idea. I can show you this last one, and no, this suggestion here, the second last one, booting the operating system in a virtual machine, it's called, which could be an alternative to booting it directly from the USB stick. I'll try to show you. Let's see, VirtualBox. Do I have that? No, maybe I don't have it. Okay, I can show you in the next video maybe. Bye bye.